According to the National Electrical Code, physical damage is defined as an impairment of the continuity of the electrical insulation. This impairment results in a direct or indirect electrical fault. National Electrical Code Section 336.12 states that electrical equipment shall not be installed in such a manner as to be exposed to physical damage. National Electrical Code Section 350.12 states that flexible cords and cables shall not be installed in such a manner as to be subject to physical damage. To understand what constitutes physical damage, it's important to consider various factors that can compromise the integrity of electrical insulation. These factors include mechanical stress, abrasion, impact, chemical exposure, and environmental conditions. Mechanical stress refers to any force or pressure exerted on the insulation that could lead to its deformation or fracture. This can occur if electrical equipment or cables are subjected to excessive weight, bending, or twisting. Abrasion is the wearing away of the insulation due to friction or rubbing against other surfaces. This can happen if cables are pulled through conduits with rough edges or if they are exposed to repeated contact with abrasive materials. Impact refers to a sudden force or blow that can damage the insulation. This can occur if electrical equipment is struck by a falling object or if cables are accidentally cut or punctured. Chemical exposure can also degrade the insulation. Some chemicals, such as solvents, oils, and acids, can react with the insulation material, causing it to swell, crack, or become brittle. Environmental conditions, such as temperature extremes, humidity, and ultraviolet radiation, can also contribute to physical damage. High temperatures can accelerate the degradation of insulation, while low temperatures can make it brittle and prone to cracking. Humidity can promote corrosion and electrical leakage, while ultraviolet radiation can cause the insulation to become discolored and lose its flexibility. To prevent physical damage, it is essential to follow proper installation practices and select the appropriate materials for the specific application. This includes using the correct size and type of conduit, supporting cables adequately, protecting them from mechanical stress and abrasion, and avoiding exposure to harmful chemicals and environmental conditions. It is also important to inspect electrical equipment and cables regularly for any signs of damage, such as cracks, cuts, abrasions, or discoloration. If any damage is found, it should be repaired or replaced immediately to prevent electrical faults and ensure safety. The National Electrical Code provides specific requirements for the protection of electrical equipment and cables from physical damage. These requirements vary depending on the type of equipment, the location of the installation, and the environmental conditions. For example, National Electrical Code Section 300.4 addresses protection against physical damage, specifying requirements for protecting cables and raceways from damage caused by nails, screws, and other objects. National Electrical Code Section 310.15 outlines the ampacity of conductors, which is the maximum current a conductor can carry without exceeding its temperature rating. Selecting the correct conductor size is essential to prevent overheating and insulation damage. National Electrical Code Section 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. These enclosures must be suitable for the environment and provide adequate protection for the enclosed conductors and devices. National Electrical Code Article 320 pertains to armored cable type AC, which provides a metallic sheath for physical protection. National Electrical Code Article 330 covers metal-clad cable type MC, offering similar protection to armored cable but with different construction and application requirements. National Electrical Code Article 334 addresses non-metallic sheath cable types NM, NMC, and NMS, which are commonly used in residential wiring. These cables are not as resistant to physical damage as armored or metal-clad cables and should be protected accordingly. National Electrical Code Article 340 covers underground feeder and branch circuit cable type UF, which is designed for direct burial in the earth and is resistant to moisture and corrosion. National Electrical Code Article 344 pertains to rigid metal conduit, providing excellent physical protection for conductors. National Electrical Code Article 348 covers intermediate metal conduit, offering a lighter weight alternative to rigid metal conduit. National Electrical Code Article 350 addresses liquid-type flexible metal conduit, providing flexibility and protection in wet locations. National Electrical Code Article 352 covers rigid polyvinyl chloride conduit, which is resistant to corrosion and chemicals. National Electrical Code Article 356 pertains to liquid-type flexible non-metallic conduit, offering flexibility and protection in wet locations where metallic conduit is not suitable. National Electrical Code Article 358 covers electrical metallic tubing, a lightweight conduit commonly used for branch circuits. National Electrical Code Article 362 addresses electrical non-metallic tubing, a flexible non-metallic conduit. National Electrical Code Article 392 covers cable trays, which are used to support and route cables in industrial and commercial applications. Cable trays must be installed in accordance with the National Electrical Code to ensure that cables are properly supported and protected from physical damage. In addition to these specific National Electrical Code articles, there are also general requirements for the protection of electrical equipment and cables from physical damage throughout the code. These requirements emphasize the importance of using good workmanship, selecting appropriate materials, and following manufacturer's instructions. By adhering to these requirements, it is possible to minimize the risk of physical damage and ensure the safe and reliable operation of electrical systems. One should consider the environment where the electrical installation is located. For example, installations in industrial settings may be subject to more physical damage than those in residential settings. In such cases, it may be necessary to use more robust wiring methods such as rigid metal conduit or armored cable. It is also important to consider the type of equipment being installed. Some equipment, such as motors and transformers, may be more susceptible to physical damage than others. In these cases, it may be necessary to provide additional protection such as enclosures or guards. Regular inspections are important for identifying and addressing potential problems before they lead to physical damage or electrical faults. Inspections should be conducted by qualified personnel who are familiar with the National Electrical Code and have the necessary skills and experience to identify potential hazards. During inspections, it is important to look for signs of damage, such as cracks, cuts, abrasions, or discoloration. It is also important to check for loose connections, corrosion, and other potential problems. If any problems are found, they should be repaired or replaced immediately. Proper training is essential for ensuring that electrical workers are aware of the risks associated with physical damage and know how to prevent it. Training should cover topics such as the National Electrical Code requirements for the protection of electrical equipment and cables, proper installation practices, and the identification and repair of damaged equipment. Training should also emphasize the importance of using good workmanship and following manufacturer's instructions. Specific examples of physical damage include a cable run across a floor where it could be stepped on or run over by equipment, a conduit system installed where it is likely to be struck by vehicles or heavy objects, electrical boxes that are not properly supported and are subject to vibration or movement, wires that are pulled too tightly during installation, causing stress on the insulation, cables that are exposed to excessive heat or cold, causing the insulation to crack or become brittle, equipment that is not properly grounded, increasing the risk of electrical shock, conductors that are not properly spliced or terminated, leading to loose connections and potential arcing, electrical panels that are not properly labeled, making it difficult to identify circuits and equipment, overloaded circuits causing overheating and potential fire hazards, using the wrong type of wire or cable for the application, such as using indoor wire outdoors, modifying electrical equipment without proper authorization or training, failing to follow manufacturer's instructions for installation and operation, ignoring warning signs or alarms, neglecting routine maintenance and inspections, not wearing appropriate personal protective equipment such as gloves and safety glasses, working on energized equipment without proper authorization or training, failing to de-energize circuits before working on them, using damaged or defective tools, overreaching or working in awkward positions, not having a clear understanding of the work being performed, not communicating effectively with other workers, not following safety procedures, taking shortcuts or rushing through tasks, being distracted or not paying attention to surroundings, failing to report hazards or incidents, not learning from mistakes, failing to stay up to date on the latest safety information. In summary, avoiding physical damage to electrical systems requires a multifaceted approach that includes proper design, installation, maintenance, and training. By following the National Electrical Code requirements, using good workmanship, and staying informed about potential hazards, it is possible to minimize the risk of physical damage and ensure the safe and reliable operation of electrical systems. This also means considering the specific environment and application, selecting appropriate materials and equipment, conducting regular inspections, and providing adequate training for electrical workers. Remember that electrical safety is everyone's responsibility, and by working together, it is possible to create a safer environment for all. It is also important to keep in mind that the National Electrical Code is not a substitute for good judgment and common sense. Electrical workers should always exercise caution and use their best judgment when working with electrical systems. If in doubt, it is always best to consult with a qualified electrical engineer or inspector. The information presented here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any changes to your electrical system. They can assess your specific needs and ensure that the work is done safely and in accordance with the National Electrical Code. Furthermore, it is crucial to stay updated on the latest revisions and amendments to the National Electrical Code, as electrical codes and standards are constantly evolving to reflect new technologies, safety concerns, and best practices. Attending training courses, seminars, and workshops can help you stay informed about the latest changes and ensure that you are following the most current guidelines. In addition to complying with the National Electrical Code, it is also important to be aware of any local electrical codes or regulations that may be in effect in your area. These local codes may be more stringent than the National Electrical Code and may address specific hazards or concerns that are unique to your region. Contact your local building department or electrical inspector to learn more about the electrical codes and regulations in your area. When working with electrical equipment or systems, always prioritize safety. Wear appropriate personal protective equipment, such as gloves, safety glasses, and insulated footwear. Use insulated tools to prevent electrical shock. De-energize circuits before working on them whenever possible. If you must work on energized circuits, follow proper lockout/tag-out procedures to prevent accidental energization. Never work alone when working with electrical equipment or systems. Have another person present who can assist you in case of an emergency. Be aware of your surroundings and avoid distractions. Take breaks when needed to prevent fatigue. If you are unsure about how to perform a task safely, ask for help from a qualified electrician. Remember, electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Ultimately, understanding and preventing physical damage in electrical installations is a critical aspect of ensuring electrical safety and reliability. By adhering to the National Electrical Code, using good workmanship, and staying informed about potential hazards, you can minimize the risk of physical damage and create a safer environment for yourself and others. So take the time to learn about the National Electrical Code requirements, follow proper installation practices, and always prioritize safety when working with electrical equipment or systems.